Hello everyone, I am Samyul. Today in this video, I am going to talk about how to find eigenvalues as well as determinant of this kind of matrices. Okay, so if you have eigenvalues, then product of eigenvalue is determinant. So you have to know how to find eigenvalues. Okay, first for this kind of matrix. Here, A that is given as a 6 cross 6 square matrix. You have to find the correct set of, choose the correct set of eigenvalues for this matrix. Okay. So, how to find? We all know about that sum of the eigenvalues, that is trace of the matrix. So, the trace of this matrix is nothing but 12. Okay. So, in option A, the sum of eigenvalues, that is 12. In option B, this is also 12. In option C, this is also 12. And in option D, this is also 12. So none of these eigenvalues, none of these option got elimination by evaluating the trace. So we have to find another approach. Okay. Now, we all know about rotational matrix. What is rotational matrix? Rotational matrix is look like this. If the matrix look like this, here the non-zero entries are same, and the non-zero entries are here 1, and here also 1. This is 3 cross 3 rotational matrix, and this is 2 cross 2 rotational matrix. Here the non-zero element can be 2, can be 3, can be -1, can be -4, and so on. Okay. Now, how to find eigenvalues for this kind of rotational matrix? For even order 2n, such that 2n cross 2n matrix, if n equals to 1, then 2 cross 2, n equals to 2, then 4 cross 4. Okay. So lambda equals to +1 for n times and lambda equals to -1 for remaining n times. If the non-zero entries are 2, then lambda equals to +2 for 1 times, lambda equals to -2 for 1 times for this matrix. Okay, if the matrix look like this, 0, 2, 2, 0, then lambda equals to +2 for 1 times, lambda equals to -2 for remaining 1 times. Okay. Now, what happened if the matrix order is 3 cross 3 or odd order matrix? Okay. Now, here in this case, for odd order square matrix, that means 2n plus 1, that means 2n plus 1 cross 2n plus 1. So lambda equals to +1 for n plus 1 times and lambda equals to -1 for n times. So what happens here? Here lambda equals to +1 for 2 times and lambda equals to -1 for 1 times. Okay. So in this way you can easily determine the eigenvalues. Once you determine eigenvalues, you can easily find determinant also, and from eigenvalue you can say the rank or the rank of the matrix also. Okay. Now, for this question, how to determine the correct set of eigenvalues? Here, you can see this matrix as the sum of these two matrices. Okay. So this is what? This is our identity matrix, which is multiplied by 2. Okay. Here 2 is in common, 2 to the power 6 in common, and this is an identity matrix. Okay. Now, why 2 to the power 6 in common? Because if you take common from any matrix, any scalar, if you common some scalar from any matrix, that that is basically k is a scalar, that is k to the power n determinant of a. This is n is the order of the matrix basically. So 2 to the power 6 multiplied by identity matrix. This is nothing but that. Okay. So for this matrix, The eigenvalues are, for this matrix, the eigenvalues are 2, 2, 2, 6 times 2. Okay. And this is a rotational matrix. So for this matrix, this is 6 cross 6. That means 3 eigenvalues will be plus 2 and 3 eigenvalues will be minus 2. So 2, 2, 2 and minus 2, minus 2, minus 2. So total set of eigenvalues for this matrix will be here. You have to sum this eigenvalues. So 4, 4, 4, 0, 0, 0. So the correct option for this question is the option B. Okay. Hope you all understand the approach, how to approach this type of question. Okay, thank you. Stay tuned.